All right, so now we're going to talk about Module 5, and Module 5 goes in your notebook on page 160 and 161. And you can see we have the flaps that go on page 160, and then the work goes on page 61, so you can kind of follow along with the picture I've included. All right, so on page 161, under the first flap, this says tangent. It says define and give an example. So I drew a picture here of a circle and a line that's tangent to a circle. And the reason why this line is tangent to the circle is because it touches the circle in exactly one place. It only intersects the circle right on the edge. So a tangent to a circle is perpendicular to the radius at the point of tangency. So also when the radius connects to that point of tangency, it's always going to make a right angle. So that is tangent. Then the next flap is secant. And so I have a picture here of a line that is secant to a circle. The reason why that line AB is secant to the circle is that it connects 2 points in a circle called a chord. The line that passes through those 2 points is a secant line. So AB, just that part, is called a chord, but then the whole line itself is called a secant line because it crosses a circle in 2 places. So now we have a couple of theorems that go with tangents and secants. And so these pictures I have drawn, they go with each of these, just so you know. So it says if a secant and a tangent line intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of the intersected arc. And we're going to look at problems in just a second so it makes sense. But what they're saying here is that this angle is going to be half of whatever that little arc is. If that arc was 90 degrees, then that angle would be 45 degrees. If that arc was 100 degrees, then that angle would be 50 degrees because it's half the arc. Okay? Then it says if 2 secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measures of the intersected arcs. So here and here, these are the 2 intersected arcs. So if this is 100 and this is 40, then this angle is going to be me adding them together, 40 and 100, 140, and then dividing it by 2. That's what they're talking about, the sum of the measures of the arcs, and that is half of that. So we half the sum. Okay. Then the next one says, basically we have 2 secants, a secant and a tangent, or 2 tangents. So basically pictures that look like this. If I want to find it, it's from the difference of the 2 measures of the angles, and it's half that. So if I find this angle, so say let's once again use 100, and this is 40, then this little bitty angle out here isn't 100 plus 40, but it's 100 minus 40. So that's 60, and then I cut that in half, which makes this angle out here 30 degrees. And it works the same if it looks more like this. These are secant lines. This is tangent secant lines. This arc and then this arc, so whatever this is minus that one, divided by 2 is going to give me the angle measure. All right, so we're going to look at these and we're going to think about how to solve them. There's a bunch of problems here and we're going to work through them, so hopefully it'll make a little bit more sense. All right, so the first thing I need to do is I have the 3 formulas. If it's on the circle, then it's just the arc divided by 2 equals the angle, okay? If the vertex is outside the circle, so if the vertex is outside the circle, then it's going to be big arc minus little arc divided by 2 is going to equal the angle. And then if the vertex is inside, it's going to be big arc plus little arc divided by 2 equals the angle. So notice with these formulas, they're all divided by 2, but one we have a big arc and a little arc. We add them in one, we subtract them in one, and then one we just have one arc. So the first thing I do is I find out where is my vertex. Here, my vertex is outside. All 4 of these problems have vertex on the outside. So they're all going to be following the outside formula, which is big minus little divided by 2 equals the angle. So here, I'm just going to write the angle. I'm going to write big minus little divided by 2 equals the angle. Then I'm going to see what is each thing. Here is my angle. This is my little, and that's my big. So I'm going to fill this into what I know. So big 256x minus 2 minus, and then I've got 106 little, 106x divided by 2 equals, and then I have 76x minus 2. This looks like a really complicated problem, but I noticed something about this problem which will make it easier. All of these numbers are even. Since they're all even, I'm going to divide them by 2. So 256 divided by 2 is 128. So I have 128x. And then 2 divided by 2 is 1. Minus 1. Minus, and then notice 106 divided by 2 is 53x equals, and then I can just write this as 76x minus 2. Now I'm going to combine my like terms, so I'm going to go 128 minus the 53, so 128 minus 53x is 75x minus 1 equals 76x minus 2. I'm going to subtract 75x from both sides. Subtract 75x from both sides. I get minus 1 equals x minus 2. I'm going to add 2 to both sides, and I see 1 equals x. Now, we didn't think it was going to come out that easy, but x equals 1. All right, and we're going to go ahead and we'll do problem 2 together as well, and then I'll let you try 3 and 4. If you want to pause and try problem 2 on your own first, you can. But problem 2, we're going to go ahead and do. So notice outside the circle, so I'm going to use this formula of big minus little divided by 2 equals the angle. So here is my angle here. This is my little, and this is my big. So this one looks a little bit different. So big minus little divided by 2 equals my angle, and that's negative 1 plus 10x. Okay, so I'm going to go ahead and do this. 175 minus 97 is 78. 78 divided by 2 is 39. So I have 39 equals 1, negative 1 plus 10x. So I'm going to add 1 to both sides, and I get 40 equals 10x, and I can see that x equals 4. So for this problem, x equals 4. So go ahead and try and see if you can do these problems. The first problem definitely was the hardest. The next one was definitely a little bit easier calculating. Try 3, try 4, see if you can do it on your own. If you have questions, feel free to ask when you come back into class. All right, now we're going to try a couple of different ones. All right, and we're going to start with 5. And the reason why we're going to start with 5 is I'm going to notice they intersect. Do you see how it's inside? It's inside. It's inside the circle. What that means is I'm going to use a different formula. I'm going to use big plus little divided by 2 equals the angle. All right, so this one, here is my angle. That's the angle T. This is my big arc. This is my little arc. So big, 160 plus little, 70 divided by 2 equals my angle, which is 56x plus 3. So I'm going to go ahead and do the calculation on this side. So I'm going to go 160 plus 70, that's 230 divided by 2, and that's 115 equals 56x plus 3. So I'm going to subtract 3 from both sides, and I get 112 equals 56x, divide by 56. And when I divide by 56, I can see that x nicely equals 2. Okay, that one was easy. I had to know the formula though. It's inside the circle, so that's going to be big plus little divided by 2. So we've done a couple 2 outside the circles. 6 and 7 are also outside the circle, so we're not going to do those. We did 1 inside the circle. Now this one, notice it is on the circle. Okay, and this one is going to be a little bit confusing, okay? Because when it's on the circle, it's just the arc measure divided by 2 equals the angle. So here is my angle here, and this is my arc measure. Now, I don't know that arc measure, but I can figure it out. The reason why I can figure it out is the whole circle is 360 degrees, and this is what I'm going to take away from it, 41x plus 8. So that's going to be 360 minus 41x minus 8. I'm going to combine my like terms here. So I'm going to get 352 minus 41x. That's going to be this part of the arc over here that I need. Okay, and so remember we said if it's on the circle, it's the arc divided by 2 equals the angle. So this is our arc divided by 2, and it's going to equal our angle. Now, when I look at this math problem, does 2 nicely go into 41? It doesn't, not at all. And so there's a simple trick that I can use to make life easier. Instead of cutting this in half, I can multiply this side by 2. I can double this side. So I get 352 minus 41x equals, and then 9x minus 1 doubled is 18x minus 2. So working this out now mathematically, I'm going to add 41x to both sides, and I'm going to add 2 to both sides. So I get 354 equals 59x. Now I'm going to divide both sides by 59. 354 divided by 59. And I get 6 equals x. Oh, it came out nicely. I didn't know if it would, but it did. So that's how you figure it out. So that's one problem where the vertex was on the circle. All right. 2 more problems. They're both on the circle. We'll go ahead and do problem 10. So here is my arc, and we know it's arc divided by 2 equals the angle. So the arc is 190 divided by 2 equals the angle, 46x plus 3. Now I already know this one's going to be a little bit easier because it's some simpler math, because 2 nicely goes into 190, 2 nicely goes into 190. So I have 95 equals 46x plus 3. I'm going to subtract 3 from both sides, so 92 equals 46x. Divide both sides by 46, and you get x equals 2. Much easier to do, so that you should be able to understand this. Now these can be a little bit confusing. You have to remember the 3 formulas. I'm going to flip back so you can see the 3 formulas. The 3 formulas, you have to remember, if it is on the circle, it's going to be the arc. If it's on the circle, it's the arc divided by 2 equals the angle. If it's outside the circle, big arc minus little arc divided by 2 equals the angle. And if it's in the circle, big arc plus little arc divided by 2 equals the angle. You're going to have to remember those for this problem. If you have any questions, make sure you come into class prepared. Ask your questions. You'll get them answered. So this is the end of Module 5.